Another hello from West Virginia. Well, a girl can try, right? Yeah. So let's try this. Let's try joke of the day because I know that you are ready and waiting for joke of the day. So according to construction professionals, what is the best side of the house? The best side of the house to put a porch? According to construction professionals, what is the best side of the house to put a porch? Well, on the outside. Okay, well, we are going to go inside logarithmic equations. So what we're going to take a look at now is logarithms and what logarithms are. Logarithms are basically another form of an exponential equation. So take a look at this. We've got two equations sitting here. X equals b to the y power and y equals log base b of x. Notice how I said that. Y equals log base b of x. Log base b of x. Notice that's exactly what this is saying. Base b to the y power equals x. So these two, being that they are equivalent equations, we can translate between the two. They are different forms of the same concept, basically. So in order to transform from exponential, which is this one, to logarithmic, what happens is you have to recognize where your base and your exponent are. So in your exponential form, you have your base b and your exponent up here written as an exponent y. So notice that in logarithmic form, your exponent now slides as its own entity. And so your exponent will equal the log of your base, and out here, this now becomes just a part of your logarithmic function, or your logarithmic equation. So, for me, the best way to translate from logarithmic to exponential, I make this circular diagram. And the way that this circular diagram works is I always say this, and half the time I say it out loud. I go like this. Base to the outside power equals the number on the inside. Do you see that circular diagram? Base to the outside power, and I say the words outside power because I'm going outside of the equation, and it's the power, equals the number on the inside. So when I do it that way and I say base, there's my base, to the outside power, now that becomes my power, equals the number on the inside. And that is how you translate between your exponential functions and your logarithmic functions. Let's take an example. Let me flip this over. We'll come back to these. But I just kind of want to work that out a little bit. So notice in this first set of examples, it says what's going to happen here is I'm going to write each of these logarithmic equations, I'm going to write it into the exponential form. And the way that you do that, again, is you go base to the outside power. So what that tells me is now in writing it in exponential form, it's going to be base 2, there's my power. So it'll be 2 to the third equals the number on the inside, equals 8. And is that true? Is 2 to the third power 8? Yes, it is. So let's try this one now. Once again, that circular diagram is going to get us there. So I go base to the outside power, so it's going to be 1/3 to the second power equals, and it equals the number on the inside. So it's going to equal 1/9. Well, is that true? Is 1/3 to the second power 1/9? Yes, it is, because this means 1 squared is 1, 3 squared is 9. That's absolutely true. So this is how you translate from your logarithmic form into your exponential form. Now, going in reverse, write each exponential equation in logarithmic form, working in reverse a little bit different. So if I'm going to turn this into a logarithmic form, that means I want log, and it always goes log base. Now notice my base is 8, so it'll go log of 8, and hear those words, log of 8. Now remember, it's much easier to go from logarithmic into exponential because of the circular diagram. So it'll go base to the outside power. So I'll go base to the outside power. That's my power. What's the power over here? The power is 2. So the power is not going to sit over here. So base to the outside power equals the number on the inside. That leftover number of 64 will go right there. So remember, base to the outside power, 8 to the second equals 64, which is exactly where I started. Now, let's take a look at the next one. Let's do it. Once again, in logarithmic form, it's going to say log base. My base here is 1/3. So log base. Now remember, this circular diagram goes base to the outside power. That's my power. The power is 3. So base to the outside power, 1/3 to the third, 1/3 to the third is here, equals the number on the inside, 1/27. So base to the outside power, 1/3 to the third, right here, equals the number on the inside, so I have translated it correctly. Now, let's go back to what I skipped over here, this idea of these common logarithms. The base of 10 is a very common base that's used all the time. Since it is so common, rather than having to write out log base 10, log base 10, log base 10, log base 10, scientists and mathematicians have just decided, you know what, when kind of like if you have a variable like this, you know that there is a coefficient of 1. You don't have to write it. Whenever you have an exponent of 1, you don't have to write it. Whenever you have a number over 1, you don't have to write it. Certain things are understood when they're not there. It's understood that this is over 1. It's understood that this is to the first power. It's understood that this has a coefficient of 1. So whenever it doesn't look like there's a base there, it is understood to be base 10 every single time. Every single time. And this is just a little bit of a shortcut that we can take so we don't wear our hands out, basically. Kind of like, don't have to write this because that'll wear our hands out. Don't have to write this or this because that'll wear our hands out. This is another little shortcut that we can take so we don't wear our hands out. Now, the other common one is your natural logarithm. We talked about that e in the previous video. So whenever you have base e, again, that one shows up a lot. It shows up in nature a lot. So therefore, whenever you have a base e, rather than having to write that out every single time, we can't write this because that indicates 10. So instead what we do is we write ln. ln is for natural log. It's a little bit backwards because that would be nl, but we write it as ln, natural log. And look, it doesn't appear that there's a base, but when you see this cursive lowercase ln, you know that means log base e. So with that in mind, let's take a look at the examples over here that I skipped over, and let's finish this out. So notice in this one, when I translate this from this logarithmic form into this exponential form, and I go base to the outside power, it doesn't look like there's a base there. But remember, we said when it doesn't look like there's a base there, it's an understood base of 10. So it's going to mean 10 to the third power. Base to the outside power equals the number on the inside, so it's going to equal 1,000. Well, is 10 to the third 1,000? In fact, it really is. So we know that that's translated correctly. And notice here in this one, it again doesn't look like there's a base, but like we said before, when we have this lowercase cursive ln, that indicates to us base of e. Just like here, that was an understood base of 10. So now that means base to the outside power, e to the 5.58 equals, but notice it's approximately equal to, because remember that base e is an irrational number. We're going to end up rounding here, so we need approximately equal to. Base to the outside power equals the number on the inside, so approximately equal to 264. And yes, that is translated correctly. So now let's take a look at these last two. We have a base of 10, so what should happen is we should write log base 10, but remember when it's base 10 we don't have to write that, so we can leave that part out. And remember, when base to the outside power, so out here should be the power, that should be my exponent of 4, equals that circular diagram, base to the outside power equals a number on the inside, so equals this 10,000. So log of 10,000 is 4, meaning 10 to the fourth equals 10,000. That's exactly what we had. So we know that's written correctly. Let's take a look at that last one. So once again, this would say log base e, But when we have log base e, we shortcut that to natural log. So this is log base e to the outside power. So out here should be the power. My power is -1. And that circular diagram says e to the outside power equals the number on the inside. So the 0.368 should go right here. And notice that I've made a slight mistake. This should not be equals. It should be approximately equal to. And so now this is translated into that logarithmic form. Don't need to show the base of e. We just simply write it as cursive lowercase ln. So I hope that this helps with this idea of the basics of logarithms and the basics of what a logarithmic form looks like. These two are interchangeable. And once again, that circular diagram, oh my goodness, that does everything for us. Base to the outside power equals the number on the inside. And that allows us to translate from exponential to logarithmic and logarithmic to exponential. I hope it helps. Have a great day.